Hello. In this example, we are going to take a look at how Flowmaster V7 can help you analyze your plant cooling systems. Effective thermal management of large, complex process plants is essential, but maintaining the safe and efficient operation of these systems can be a constant challenge. Whether analyzing utility streams which are constantly operating, such as preheating of raw materials, or designing standby systems, such as a backup system that provides emergency cooling water to a reactor, you can leverage Flowmaster V7 to help ensure these systems operate as intended. So let's take a look at the system we're going to look at today. We start off with a chiller unit, which is going to store the water as well as bring it down to the operating temperature. We have a pump system, and then we have this leading into two systems, product temperature control and the reactor cooling jacket. So with Flowmaster V7 you have several options of how to specify thermal properties in your system. With the chiller unit, we know a specific temperature that we want to output, in this case 20 degrees. But when we look at the product temperature control and the reactor cooling jacket control, we just have a specific amount of heat that we know is going to be put into the cooling system by those particular parts. So for this, what we want to do is look at sizing our pumps to start off with. And so we can input our own information, such as the pump manufacturer's head and torque data. And we can go ahead and we can run our analysis. So for this particular one, we can look and see what type of flow rate we have coming out of our pumps, which we would expect to be able to generate the proper temperatures coming out of the systems, but also to investigate to make sure that the efficiency of the pumps is running in an adequate range, so that we have a little bit of energy that we can still put into the system should we need to move more water due to different operating conditions. So with this we can see that we have our system running at an adequate efficiency out of the pumps, and our cooling water is at the proper temperatures coming out of the different services. So with this we can then also look at a transient analysis, so we can see how the dynamic behavior of the system will change. One of the strengths that you can utilize Flowmaster V7 for is the prediction of pressure surge and of cavitation in the system. So we can look at an emergency example where we may have a pump malfunction or trip, as well as trying to close off certain parts of the system. Well, with a pump, anytime we shut it off, there's going to be a certain amount of inertia still going on in the system to make sure that the pump comes to a complete stop. If sections of the system are closed down too quickly, what we can get is a cavity that forms on the upstream side of the pump. As we can see here, we could then work on understanding how quickly and when we can close any sort of valves to prevent that. As we showed with the heater-cooler element of Flowmaster V7, we can add just a certain amount of heat to the system. We also have the option to use a two-circuit heat exchanger, such as a shell and tube heat exchanger. And here we have several options we can look at. We can again put in thermal duty. We can also look at temperature rise or temperature drop, or we can look at thermal effectiveness, which is what we're going to use in this example. Here are some of the advantages we have, is we can actually account for the product stream. And so we can set a specific input temperature and flow rate or pressure of the product stream, and we can see how that's going to end up affecting not only our cooling stream but also our product stream, so we're able to look at more information. A third example of how we can use Flowmaster V7 for our heat transfer needs is the use of solids components. And this allows us to model any type of solid, such as the reactor cooling jacket, using components that account for the thermal mass as well as different options of heat transfer, such as the radiation, convective, and conduction going on from the metal. Here we've entered the mass of the reactor cooling jacket as well as an initial temperature. And what we can see is, given the cooling system, setup, how long is it going to take to reduce that reactor to a certain safe operating temperature? If you have any questions or would like any additional information on how you could start solving your fluid system challenges with Flowmaster V7, please contact your local sales office. Thank you.